Hello, dear students, friends. Today there was a discussion about the inverse functions derivative early in the morning. Well, it's been requested that the reference is required even after the discussion. So the specific video has been made. Now, I'm not trying to stick to the details of inverse function, but I'll try to make a sense of basic formulae and basic definition of the inverse function. So here how it goes. Dy by dx is what they call as a derivative of y with respect to x is equal to 1 upon dx by dy. This particular fact is being used everywhere. How is to be proved? I can say, suppose if y is equal to f of x is any particular function in x, delta x may be the change in x, dy may be the change in y. So dy by dx, according to the definition, it says limit of delta x tends to 0 of delta y by delta x, as how they said, and dx by dy. If I take a limit of delta y tends to 0 of this, it's gonna give me dx by dy. So suppose if I say like this, dy by, oh sorry, not like this. Suppose delta y by delta x is equal to 1 upon dx by dy. Then limit of delta x tends to 0 of delta y by delta x is equal to 1 upon limit of delta x tends to 0 with respect to delta y also tends to 0 of delta x by delta y, which gives again the fact that dy by dx is equal to 1 upon dx by dy. This particular derivation was expected in many of the cases. Recent things might have changed. So I think you all should refer about it. So now let's start. Y is equal to sine inverse x. From this, I can imply x is equal to sine y. So I'll differentiate this with respect to y. So I'll say differentiating with respect to y. I'll get dx by dy as cos y, which I should write as root of cos square y, which is equal to root of 1 minus sine square y. I substitute back again sine, which is 1 minus x squared. So now dy by dx, according to the definition, we're going to be 1 upon dx by dy, which is equal to 1 upon root of 1 minus x squared. So I have derivative of sine inverse x as 1 upon root of 1 minus x squared as the first part. Let's move ahead. Go for the next part as y is equal to cos inverse x. I'll get x is equal to cos 1. So again, I'll differentiate this with respect to x, sorry, y, differentiating with respect to y, we get dx by dy is equal to minus sine y. So which is equal to minus root of sine square y is equal to root of 1 minus cos square y minus, which is equal to minus of root of 1 minus x square. So therefore, dy by dx will gonna be 1 upon dx by dy according to the definition. So it will be minus 1 upon root of 1 minus x squared. That's cos inverse x. And we'll go for y is equal to tan inverse x. Situation stays same. So I'll say x is equal to tan of y. I'll differentiate this with respect to y. So I'll get differentiating with respect to y as dx by dy is equal to sec square y, sorry, is equal to 1 plus tan square y. So I substitute back tan y as x, so I'll get 1 plus x square. So therefore, dy by dx is equal to 1 upon dx by dy, which is equal to 1 upon 1 plus x square. So therefore, y is equal to tan inverse x dy by dx is equal to 1 upon 1 plus x square. And let's go for the next. Y is equal to sec inverse x. So x is equal to sec y. I'll again differentiate this with respect to y. So I'll get dx by dy is equal to sec x derivative is sec x tan x. So sec y will gonna be sec y tan y. I had to express this entire expression as in terms of sec itself. How I do it? I'll get sec y root of tan square y. So sec y will gonna be 1 plus tan square is equal to 1 plus tan square is sec square. So tan square will gonna be sec square minus 1. Sec square x minus 1. Sec square y minus 1. So I'll get x into root of x square minus 1. So therefore, dy by dx is equal to 1 upon dx by dy. I'm avoiding all those complicated situations and trying to be simple just to get manipulated with all the formulae and maybe some basic proofs. So I'll get x root of x square minus y is equal to sec inverse x as how we get it. So we have y is equal to sec inverse x dy by dx is equal to 1 upon x root of x square minus 1. Next is sec inverse x. So I have y is equal to sec inverse x. I'll get x is equal to sec y. Differentiating with respect to y. Sorry. I do get dx by dy is equal to minus cosec x cot x cot x 1 plus cot square is equal to cosec square. 1 plus cot square is equal to cosec square. So cot square will gonna be cosec square minus 1. Cot inverse na baba. Cot. This is cot. So I'll write cot square y minus cosec y cot square. 1 plus cot square is equal to cosec square. So cosec square y minus 1. And if I resubstitute cosec y as x from this, I do get minus x root of x square minus 1. So therefore, derivative of cosec inverse x d by dx of cosec inverse x will gonna be minus 1 upon x root of x square minus 1. And we get the formula as this. So sine cos tan cosec sec, and the last but not the least is cot y. What we're gonna go for? How I'll do it? Y is equal to cot inverse x. Y is equal to cot inverse x. So x is equal to cot y. I'll again differentiate with respect to y, dx by dy. Cot x derivative will gonna be minus cosec square x. So no more confusion. 1 plus cot square is equal to cosec square. So cosec square will gonna be minus into bracket 1 plus cot square. Every time after differentiating whatever the expression we have, I'll try to express in terms of x, and we get as minus into bracket 1 plus x square. So therefore dy by dx will gonna be 1 upon dx by dy, which is equal to minus 1 upon 1 plus x square. And that's the final part, minus 1 upon 1 plus x square. I think it's not that good. So let's make a list of all the formulas, whatever we have learned. Tan inverse x, 1 upon the root of 1 minus x square. Cos inverse x will gonna be with a negative sign. LP minus 1 upon root of 1 minus x square. Then tan inverse x will gonna be 1 upon 1 plus x square. Cot inverse x, of course, cos c's, all c's are negative. There will gonna be with a negative sign, minus 1 upon 1 plus x square. And last but not the least, sec inverse x will gonna be, of course, let's write the equal to signs. 1 upon x root of x square minus 1. There is mod also, or something is there if you take all the consideration of angle, quadrants and everything, but I'm not dealing with that at present. I'm stick to the proper basic formula. Sec inverse x, 1 upon x root of x square minus 1. So the sec inverse x will gonna be minus 1 upon x root of x square minus 1. And that was like that. Half angle formula, whatever they were needed for all these substitutions. Let's say sine inverse x. What sine inverse x? Sine 2x. Is equal to 2 sine x cos x, 2 tan x upon 1 plus tan square x. Then cos 2x, I should say cos square x minus sine square x, 1 minus 2 sine square x, 2 cos square x minus 1, 2 cos square x minus 1, and the last but not the least, 1 minus tan square upon 1 plus tan square. Then tan 2a will gonna be 2 tan upon 1 minus tan square. Okay, triple angle formula. Let's discuss even that also. What are the triple angle formulae? We'll say sine 3a is equal to 3 sine a minus 4 sine cube a cos 3a is equal to 4 cos cube a minus 3 cos a. and tan of CA. 3 tan A minus tan cubic upon whole divided by 1 minus 3 tan square. This can be achieved, by using tan 2A plus A, which is tan 2A plus tan A upon 1 minus tan 2A tan A. And substitute for tan 2A, apply some good algebra, we should get back to the result. That must be an homework. Think about it. Chalo. Thank you and thank you very much.